Thank you so much, Amy. That was really, really cool. Next up, we have Lauren Runnels with a presentation titled Chemical Analysis of Chondria tumulosa for Rhodophyta. Everyone welcome up Lauren.
Hi, my name is Lauren, and today I'll be talking about a chemical investigation I did on this red algae species called Chondria tumulosa.
There's a mic on?
Oh.
Can you lift it up a little bit? I can do it.
Does this change the slides, by the way?
Yes, it does. Just
Do I need to say that again? So my name is Lauren, and today I'll be talking about a chemical investigation that I did on Chondria tumulosa. So Chondria tumulosa is an invasive macroalga in the northwestern Hawaiian Islands, specifically in the Papahanaumokuakea Marine National Monument. It's a very remote location, has minimal anthropogenic influences, so not a lot of human interaction going on. So in 2016, this species was first observed by NOAA scientific divers, and in 2019, it was described as a new species, Chondria tumulosa. It's located in Pearl and Hermes Atoll, and it is also spread to Midway Atoll. So Chondria tumulosa shows typical invasive species characteristics, such as fast growth, rapid reproduction, and high dispersibility. There's also a lack of herbivore grazing, and as seen in this picture, Chondria tumulosa is overgrowing coral and competing with other algae species on the reef. So the lack of herbivore grazing may suggest secondary metabolites present in the alga. So just for a geographical reference, here is Hilo in the little red section right here, and 1,400 miles away is Pearl and Hermes Atoll. So quite far away from where we are. So the objectives of this study was to investigate the secondary metabolites in Chondria tumulosa, but also understand a program called Global Natural Products Molecular Networking System to develop a dereplication method for natural products analysis. And I also wanted to explore methodology for liquid chromatography mass spectrometry and conduct preliminary bioactivity tests. So here's my analysis process. So first I extracted C. tumulosa with methanol, dichloromethane, and hexane, to which then I took that methanol extract and did liquid chromatography mass spectrometry. Liquid chromatography separates the compound based on polarity, and the mass spectrometry is kind of the detector. It tells you obviously the mass, but other things about the compound. And then I took that chromatogram from the LCMS and I did a manual inspection and identified major peaks present in the spectra. And from those major peaks, I extracted the exact mass and also the masses of the different ionizations. And with that data, I inputted into the American Chemical Society SciFinder database to see if I could get any hits on those masses, which I did not, so that was interesting. So then also with that methanol extract, I performed a solid phase extraction to desalt the extract, which allowed me to perform a Kirby-Bauer bioassay with E. coli and B. cereus to see if there was any preliminary antibacterial compounds. So I also did flash chromatography, which is a large silica column that fractionates the compound similarly by polarity. And then I TLC'd, or thin layer chromatography, those compounds to observe the separation. So in here, outlined in blue, is my GMPS process, or Global Natural Products Molecular Networking, to where I created 28 standards and then analyzed those via LCMS as well. And then I took those standards and I manually inspected the chromatograms for strong peaks and low noise, so it would be a good candidate for the database to pick up on. So, So here is my chromatogram of the methanol extract of the C. tumulosa. So this is the crude extract. And as you can see, the major peaks are labeled and they correspond to these tables. So I assigned those masses molecular formulas. They're all good organic compounds. But the positive of doing kind of this preliminary LCMS with the crude extract is it allows me to identify these major peaks and masses, so when I do targeted LCMS, I have more of a goal and know what to look for. So in order to do the flash chromatography, I first had to develop a solvent matrix to properly separate all the compounds. And I used a preliminary TLC, or thin layer chromatography, to test out different solvent concentrations. So I tested out hexane and ethyl acetate and methanol and dichloromethane. So I found that a solvent matrix of methane and dichloromethane worked the best, from 2 up to 10%. And then since there were a little bit of compounds still stuck here on the spotting area, I eluted the compounds off completely with ethyl acetate. And from the fractionation of the column, I ended up collecting 37 fractions. So here are some of my results for the Global Natural Products Molecular Network. So this standard over here was my hydrocortisone standard, and that first graph is the chromatogram, and as you can see, there's a nice strong peak indicating the presence of that pure compound. And then below is the mass spec, and then the MS data, which is the fragmentation of that mass spec. So these fragmentation patterns act as the fingerprint for these chemicals. So out of the standards, only 11 of those standards were clean enough to be a good candidate for GMPS. And when I ran those 11 through the database, I only got 7 positive hits. And this could be due to numerous amounts of factors, but to achieve more quality MS spectra, we would need to optimize the LCMS conditions by trying different collision energies and possibly switching from our positive ionization to negative ionization to catch some of those other compounds that we didn't observe peaks for. And also alternate the spray conditions. So better resolution, we get better peak identification from GMPS. So here's some more GMPS data. As you can see, there's a table of all my standards and then the outputs from GMPS. So this cosine score column is kind of a measure of the similarity, and anything above 0.7 identifies a significant hit. So as you can see, all of them are over 0.75 except those ones with Na, which GMPS did not pick up at all. And here's the graph of what GMPS actually outputs. It shows in green the spectra from the database and in black yours. So it allows you to really comb through your spectra and make sure that's a good match. So my conclusions is I did create a molecular network of amino acid standards using GMPS that will allow me to potentially discover novel compounds or see different compounds with my Chondria extract. I collected 37 fractions from the methanol extract from the flash column, which will then be analyzed using GMPS because that will hopefully put cleaner compounds. I observed no zones of inhibition on B. cereus or E. coli as seen in these 2 photos. So there was no bioactivity that could be observed, and this could have been due to very small amounts or low concentrations of antibacterial compounds. So I developed a TLC and chromatography conditions that I will continue to be using for my future C. tumulosa analysis. And then some of my next steps is I would like to perform feeding trials to observe the ecological significance of this alga, because as stated before, there's a lack of herbivore interactions, and I'm curious too if this is due to the secondary metabolites. I would like to do it with collector urchins. I also want to continue doing GMPS dereplication and target analysis of Chondria known compounds that are found in the literature. And I also have hexane and dichloromethane fractions that are still analyzed. And I would like to thank all these people for helping. Thank you. Any questions? Okay, yes.
Do you know the rate of how fast it's spreading?
I don't know the exact rate off the top of my head, but I know it's becoming like a super long trail on the reef slopes. So over even the last 3 years, there's been extreme significant growth to where it's becoming a problem. Yes.
Is it found on this island?
It is not. It's only found on Pearl and Hermes and Midway. So
Lauren, of any of the compounds that you isolated, have any of those been shown to have like inhibition effects on other species?
Do you mean like other species of bacteria?
Other species of algae, other reef species like fish and urchins?
All of theirs kind of noticed there's no like herbivore grazing on it or lack of. So no one really knows why. That's why I'm kind of investigating the secondary metabolites to see if it's more of a chemical thing or a structural defense, because it does have like little kind of spines on it almost. But per literature review, there are other Chondria species that have antibacterial properties to other bacteria. Does that answer your question, kind of? Yeah, okay. Anyone else?
Thank you so much, Lauren. That was really awesome.